Hello everyone, welcome back to another video. Today we'll be talking about our first data structure called arrays. So what is a data structure? Data can be any data type we have talked about so far, like int, double, float, char, string, and all other types are all considered data. And a structure is a way of holding a group of data. So we can hold multiple values in a data structure. We can't mix and match different data types in an array. So all the data in an array has to be of the same type. So an int array will only have integers, and a character array will only have characters. We won't ever have an array that has both float and integer, or both character and string. Even we can't have a double and float or short and long. Those cannot be in the same array. So let's look at how we define an array. Let's say we want to define an int array, an integer array. So we say int, and then we put brackets around. The bracket tells us that it's an array. Then we put the variable name. So I'll call it ARR, short for array. Then we say equals new int. And for an array, we have to specify its size. Array sizes don't change. We cannot change a size once we've set it. So let's say we just want it to be of size 5. This is how we declare and define an empty array. So how do we print an array? Well, there are two ways we can print an array. We can loop through its values or use a shortcut. I'll show you the looping way first. The looping way would be for int I equals 0, I less than. We want to go to the size of the array. So the size is 5, but we might not always want to use 5. So Java provides us with a little helpful tool we can use, which is .length. So we type our variable, our array name, and then .length. .length will give us what the length of the array is. And then we do I++. And then in here we can do system.out.printf, and we can do %d, and we can print out each individual element of the array. We set our size as 5, that means we have 5 elements. And how we access the element is ARR, and then in our brackets we put in I. Because the I is what is changing. We're changing from 0 up until the length, but not including the length. So you might be thinking, why did we start at 0, and why are we going up to the length but not including the length? This is not less than or equal to, it's just less than. So how arrays are structured is, suppose we have an array, as we have. Right now, we didn't define our array, so the default array values are 0, 0, 0, 0, and 0, because we didn't specify what those values are. So the element of an array is the value inside the array. So the elements are going to be all zeros. And we also have a term called an index. Now the index, let me erase this. The index of an array is its location. So right here we say ARR at I. This is how we access its location, by putting the I in the brackets. So we say the index is the I. I is the index. So right now we're going to go from 0 up until the length, which is equal to 5. So this index right here, the first index of an array is 0. The second is 1, and then 2, and then 3, and then 4. If we say ARR at 0, it'll give us this number. ARR at 1 will give us this number. To make this easier to understand, I will change the values as an example. Let's say we have 3, 6, 8, 2, and 9. So if we say ARR at 0, we look at the index. This is the index in here. So ARR at 0 gives us 3. ARR at 0 is 3. ARR at 1 would give us 6 because the index is 1. So it's 6. This is how we tell which value inside the array we want. We refer to it by its index, or we can say the reference, we reference it by its index. So referring to or referencing the index. We're saying ARR, and then in our brackets, we're writing its index. And inside its index, we see that the value is 6 for 1. For the index 1, the value is 6. For index 0, the value is 3. And so on and so forth. So ARR at 2 gives us 8. ARR at 3 gives us 2. ARR at 4 gives us 9. And this is just for our example purposes, but in the code we have written here, when you say new, it will default all values in here to 0. So ARR at 0, 1, 2, 3, 4 will all be 0. Now this is also where it gets confusing because the index goes from 0 to 4, but the length is 5. This is why we use the less than operator. We do not want it to equal 5 because we did not define the index 5. If you go out of bounds of an index, so the bounds are from 0 to 4, we can do array at 0, array at 1, array at 2, array at 3, and array at 4. We can do all of this. If we do ARR at 5, if this comes up in our program anywhere, then we will get something called an out-of-bounds exception error. An out-of-bounds exception error means that we went past the maximum value that we can. We did not give it enough space. We only gave it 5 spaces, which is 0 through 4. We didn't give it a 6th space. So this gets kind of confusing, but let's run this, and we should see in our example that we've written down over here, we should see all zeros being printed out because the default when you use new int 5 will give you all zeros. So let's run this. And we get 5, 0, 1, 2, 3, 4, and 5. We get 5 zeros. So what would happen if we change this to a double? The default value for a double. And if we're doing a double, we want %f. And we run this. Then we get 0.000000. So you can experiment with what the default values are. This is the long way to print out an array. The shortcut way to print out an array is system.out.printf %s. We actually print it out as a string. And in order to use this, we have to import java.util.arrays. So java.util.arrays, this is an import. Imports are special built-in Java features that we can use. This is one of them for arrays. So what we can do is say arrays.toString and then ARR in the parentheses. This is a shortcut for printing out arrays. So if we run this, we will see 0.0 because the default double value is 0. So arrays.toString, and you have to remember to import java.util.arrays. This is something that Java provides, and we use arrays in toString. Arrays.toString, and then we have our value inside the parentheses, or our variable inside the parentheses, the variable of our array. So you can either use this shortcut by printing it as a string, or you can cycle through it with a for loop. So these are two ways to print, but there are many more ways to define an array. Rather than defaulting our values to 0, we can assign values by ourselves. And how we can assign values is with these curly braces. And let's say we want the same values as our example. We want 3, 6, 8, 2, 9, and it's actually an int 3, 6, 8, 2, 9. So if we printf arrays.toString, we should see 3, 6, 8, 2, 9 printed out. We'll see 3, 6, 8, 2, 9 printed out. With the toString, it also prints out the opening and closing brackets. But if you use the loop, we can format it how we want to format it because we're individually printing each value. So if I do for int I equals 0, I less than arr.length, and then I++, and then we say system.out.printf %d, because this is an integer array, and then we say arr at I. We are going to be printing out each individual number on a new line because of the \n. So we can run this, and we will see 3, 6, 8, 2, 9. And if we want to, we can also print out the index. Let's say index is %d, and then we want value is %d. So I can put an I here. So we'll see index is %d, which will be the first one, which is I, and then value %d, which is the actual value. So this will probably show something similar to this. And I think it'll help us give us a better representation of what's actually going inside. So index 0, value 3. That makes sense. 0, value 3. Index 1, value 6. Index 1, value 6. Index 2, value 8. 2, value 8. Index 3, value 2. We have index 3 is value 2. And then we have index 4, value 9. And we have that there. Now notice that inside here we don't have to define the size, because when we do the curly braces, we know which values we already want. If we don't know which values we already want, that's where we want to use the new keyword. So this is a short introduction to two different types of ways we can define arrays. Suppose we have an array and we want to redefine our array. Maybe we thought that maybe we don't want these values in our array anymore. So suppose we want to redefine our array. We can't just redefine it with values. We have to redefine it with arr equals new int, and then we have to give it a size. So we can resize our array, and if we try this, then we don't have to change this. We could have put 5, but instead we put array.length, and this dot length will change because now it's 3. So to redefine our array, we have to use new, and then we have to give it a new size as well. If we wanted to keep the same size but change the values, then we could do array at 0 equals 1, and then maybe array at 1 equals 2, array at 3 equals 3, array at 4 equals 4. So now we've redefined array at 0 is 1, so this one would be 1, array at 1 is 2, 3, 4, oh, I forgot the 2. Array at 2 equals 3, and then 4 and 5. So array at 0 is 1, array at 1 is 2, array at 2 is 3, array at 3 is 4, and array at 4 is 5. So if we redefine our values like this, then we should see 1, 2, 3, 4, 5 as our values. The indexes should stay the same because the sizes stay the same, but our values will change. So if we save this and run it, we'll see index 0 value 1, index 1 value 2, index 2 value 3, index 3 value 4, and index 4 value 5. And this is reflected in how we change the element through the index. So we can use values like this. If we want to say that, if we just want to print out an individual element, we can do system.out.printf. We can do %d\n and just say arr at 0. And we can say the 0th element is array at 0. So what we should see printed out is the 0th element is, and then %d, which is array at 0, and we've defined array at 0 to equal 1. So if we run that, we'll see the 0th element is 1. We can use individual values, we can change individual values. If we want to change the entire array, then we have to use the new keyword. So if we wanted to make array equals new int, and we want it to be size 3, we wanted to completely change it, we'd have to use new, and all the values would be defaulted to 0. So if we save it and run this, then we would see the 0th element is 1, because over here it's done this part, we've done this, we've assigned it, and then we've reassigned it over here. Then we printed out the 0th one, which was 1 over here, so that's why it says the 0th element is 1. But then we said, I want to scrap everything and I want to start over. I want to say that there's a new int size 3 array. So then it goes in here, and array.length is now 3. So we go from 0, 1, 2. And that's why we have index 0, index 1, and index 2. And all of their values got defaulted to 0. Because when you use new, everything defaults to 0. So we can modify the individual values of a previously defined array. We can completely wipe an array by using the new keyword. And maybe we want to wipe the array but keep the same size. We could do that as well. We don't have to change the size. We could just keep the same size but completely wipe the array. If we run this, we'd say the 0th element is 1, which comes from here because of this. And then we just want to wipe it clean. And then over here in this loop, it'll go up to 5 because we've defined the new size to be 5. So it'll go up to 5 and it'll print out index 0, value 0. All the values are 0 because we wiped it clean, but it has the same size. So we don't have to change the size. So we talked about arrays, we talked about indices, we talked about our shortcut for printing with java.util.arrays. And one last thing is our new type of loop. Our new type of loop for printing arrays is called a for each loop. So in a for each loop, we say for, and the first part of the loop is the data type and the variable. So I'll say int, because we have an integer array, so we need to keep the same data type, int, and I'll just call this var for variable, and then we have to give a colon and then we give the name of the array, and we named our array ARR. So how this is read is for each var in array, and then we can do system.out.printf %d, and we can print out the var. So what this will do is, instead of in our last for loop where we had to cycle through the indices of the array, in this one we're cycling through the values of the array. So the var will not hold the values 0, 1, 2. It'll actually hold the values, well, in this example, if we use this example in the comments, it would not hold the 0, 1, 2, 3 values. Var would hold the 3, 6, 8, 2, 9 values. So let me erase this part so that we have our example back. So var would not hold 0, 1, 2, 3, 4. Var would actually hold 3, 6, 8, 2, 9. So I'll write var equals %d \n var so we can see what var is. And I will also erase this part because we know that the 0th element is 3. So if we run this, we will see var equals 36829, which is the actual value that the array is holding. Compare this to a regular for loop where we had for int I equals 0, I less than arr.length, and I plus plus, and we just use I. When we print out I, we'll actually print out this I variable, which is looping from 0, and it's doing a plus plus every time through the loop until we reach 5, but we don't go in at 5, we stop at 5, so it'll go from 0, and we will see 0 through 4. So right now, or I should actually change this to I equals rather than var equals. So I equals 0, 1, 2, 3, 4 in a regular for loop, whereas in a for each loop, we would have for each int var in our array, and then we would say var, and we would change this to var as well. And then we would actually have the value. So it depends on whether you want the value or you want the index. Whichever is your preference, you can use either or. Sometimes if you're doing things not in order, then you want to have access to the index, because you might want to go back or forward one index, but you wouldn't be able to do that with a for each loop. For each loop should be used when you want to do stuff in order and you don't want to go back or forward in the array. In the next video, we will talk about more examples with arrays.